Okay, good morning, good afternoon, or good evening, whenever you are watching this video. Let us welcome you all to our channel, Future Endeavors. First of all, I want to thank you all for supporting this channel so dearly. Your support, your likes has really inspired me to carry on this channel and upload further videos, and I think the previous two videos have helped you a lot to see science in a bit different way. So with that motive, to help you understand science in a better way, I will start my today's lesson. As ended on the previous class, we are discussing about the various states of matter, and we have done a comparable study between the three states of matter: solid, liquid and gas. Now we will move on to the next part, but before moving on to the next part, I would like you to say something. Please do comment and let us know your inquiries. What do you want? What are your requirements? I will try to fulfill those requirements, and please do support us, please do like our videos, and please subscribe our channel and press the bell icon so that you can get every notification of the new videos that are being uploaded. With that, okay, I will move on to my topic quickly. Now in the previous class we have discussed about the three states of matter: solid, liquid and gas. In today's class we will discuss about the various processes involved in the conversion of the matter from one state to the other state. So today's our topic is interconversion of states of matter. Interconversion of states of matter. So see, if I think that when you take out a piece of ice from the refrigerator and hold it in your hand, you see that the ice cube slowly starts converting into water. Likewise, when you put a bowl of water on the gas stove and start heating it, you see that slowly the water gets converted into vapor state. So I can say that a matter is converted from one state to another state. Definitely one important factor affecting that interconversion is the application of heat. Rather, I can say it like this, that the ways or the factors which we can utilize in changing the states of matter are two, not one, are two. We have, in general, you see that when you either heat or cool a particular state of matter, there is an interconversion. Okay, so this interconversion of matter can be done by, so this interconversion can be done by one is by heating or cooling, that is by changing the temperature. And the second factor or the second way by which we can change the state of matter is, second factor is by changing the pressure. I will discuss about this factor briefly. So these are the two ways by which you can change the state of a matter. Now, okay, I would like to mention one thing. Those who are actually seeing these videos for revision purposes can go to the settings of the YouTube and you can actually change the speed of this video. If you like, if you wish that the video is being a bit slow, you have already learned these things, you are doing a bit of revision, you can put it onto the 2x mode. There are quite few modes, 1.5, 1.25, 1.75, 2. So you can change the speed, and if you think that it is a bit being slow, you are doing it for revision purpose, you can increase the speed of the video. Okay, now let us come back to the point where I have left. We are saying that we can change the state of matter by either heating or cooling, that is changing the temperature, and we can also change the state of matter by changing the pressure. Say I will give you an example. So how can you change the state of matter by applying or by changing the pressure? Let us see. Just a very simple example. I think it will be very helpful to you. See, I consider that there is a container having a piston on its upper surface, upper frame. Okay, piston on its upper frame. There is a container having a piston. What is a piston? You can say, rather you can see it is a airtight system which actually do not allow the air to pass out or any air to pass in from the outside. Such a arrangement is called the piston system. And say you have certain gas molecules present in this container, closed in this container. So there are quite a few molecules, okay, as you can see, or say rather particles of gases. Now how can we increase the pressure? Say if I apply a force from the upward surface, or say you just put some bricks over this piston. What will happen when you put some brick over this piston? Say I have put 2 bricks on this piston, okay, or a large brick, say rather I have put out a large brick which have some weight. I have put out a large brick. What will happen? The piston will slowly start moving down. What will happen? In the very next phase, in the very next part, what will happen? The piston will come down. It will start coming down. So in the next diagram you can see that when you put the brick on the piston, it slowly moves down. Now say it have come to this level. Previously it was at this point, okay, now it have come down and it has come here, okay, with the brick on it, okay, fine. Now as the brick comes down, you see that the particles that were present, I think there were 5 to 6 particles present, okay, or say rather 7, they come very close to each other. Now they are coming close to each other. There are number of particles remain same, but they come close to each other. As they come close to each other, you have already studied that as the molecules come close to each other, they slowly get converted from the gaseous to the liquid phase. And if you further compress it, think from the that point of view, if you further compress it, the molecules will further come close and it will be nearly moving on to the solid phase. Okay, so in this way you can change the state of a matter by applying pressure. So these are the two ways by which you can actually change the state of a matter, by either changing the temperature or by changing the pressure on the particular matter. So these are the two ways. Now let us see what are the various types of interconversion. What are the various types of interconversion? If you think of what is interconversion of matter, the change of state of matter from one state to another state can be referred to as the interconversion of matter. Now see, there are three states of matter: solid, okay, then goes liquid, and the third state is the gas. In general, you see these three states: solid, liquid and gas. I have mentioned that other than these two states, there are two more states which you do not see generally around yourself. I have discussed it in the previous class. You can go on to the first lecture and see it. Okay, so now if I think, how can I convert the solid to liquid or liquid to gas, or the vice versa? See, if I say that I want to convert the solid to liquid, first just note it down, I will explain it. I want to convert the solid into liquid. What is this process called when I am converting a solid state into a liquid state? This process, as you know, is called melting. Is called melting. Okay, it's called melting. There is also another term, if you know, fusion. So these are the two terms, fusion or melting. If you want to convert back the liquid into solid, then what is the term used? What is the term used? This term can be referred to as freezing. So note it down, it is said to be freezing. Okay, so these are the two processes. Now if I say of converting a liquid into gas, liquid into a gas, what is this term called? This term, as you know, is called boiling or vaporization. Boiling or vaporization. Boiling or vaporization. And when you convert back the gas into liquid, that is said to be, what is it said? It is said to be condensation. So I can say when gas is converted into liquid, it is said to be condensation. Now in some cases you see some solids when heated get directly converted from the solid state to the gaseous state. Now when you directly convert the solid into gas, this process is called sublimation. Many of you have heard this term, sublimation. I will discuss all these terms one by one. Just let me summarize it first so you can have a brief idea. And the reverse process, if I convert this gas directly into solid, then that process is called solidification, or can also be referred to as deposition. So deposition or solidification, this is the two terms. Okay, fine. Now as I have already mentioned you about the various processes, let us just see one by one what are these processes called, or what are these processes are about. I will define each process so that it is easier for you to note it down. So I hope you have taken the chart in your notebook. Let us erase and move on to the various processes. Okay, so I am just erasing it out. Okay, so now if I think that I want to convert a solid into liquid, so what is that process called? It's called melting or fusion. Now what is this melting or fusion? What is this melting or fusion? So if I just define it, I can say that it is a process. First of all, you need to understand that melting or fusion is a process. So it is a process in which a solid changes into a liquid at a particular temperature. Now this point is very important. You need to understand, this point is very important. At a particular temperature, So melting or fusion is a process in which solid changes into a liquid at a particular temperature. If you don't mention this term, the definition is not correct. You have to mention that this term. I am explaining it. What does it mean? First note it down that it is a process in which the solid changes into liquid at a particular temperature. Okay, I hope you have noted that down. Now just think, when we change a substance, solid substance into a liquid, that process happens at a particular temperature. Say when you are observing that a ice is melting, and if I keep a thermometer to record that temperature during the process of melting, you will observe that when this process is occurring, that is when the solid is slowly changing into liquid, from the time when it is totally ice, say we are thinking of melting of ice, up to the time when it is totally converted into water. Remember, during this time temperature is conserved. Okay, so the temperature remains fixed. Remember it, temperature remains fixed. Okay, now if I think the reverse process, then suppose you are keeping a tray of water in the deep fridge of your refrigerator. After a few hours you see that the water has converted into solid ice. So what is this process called? In general, I can regard this process as freezing. We often say that water has freezed into ice, so the process is called freezing. So how can I define it? To define it, I will say, again I am noting it, it is a process. Remember, it is a process in which a liquid changes into a solid at a fixed temperature. I think by now you have understood what I am trying to say by saying or mentioning at a fixed temperature. This point again I am saying is very important. You cannot miss it out in the definition. So I will say that freezing is a process in which a liquid is converted into a solid at a fixed temperature. Now after these two definitions are clear, I think it is clear to you and you have also noted it down. Another term is to be mentioned here, that is the freezing point or the melting point. Freezing point or the melting point, both are same actually. Why I am saying that these two terms are same, just see the definition, you will understand. Melting or freezing point. Okay, first of all, it should be clear to you that this melting or freezing point, it is actually a particular temperature. See, the previous two definitions I have mentioned that it is a particular process. Now I am saying that it is a particular temperature at which what happens, either at which solid changes into liquid or the reverse can be also said, liquid changes into solid. I think the definition is clear. Just see, when you are defining the term melting point, just mention this. So what will be the definition of melting point? I am repeating it. It is a particular temperature at which a solid changes into liquid. When you are defining the term freezing point, then you mention this point. Freezing point is a particular temperature at which a liquid changes into a solid. See, now the melting point and the freezing point are both the same temperatures for a particular substance. Why I am saying this? See, when you think of water, it freezes at 0 degree centigrade, also it melts at 0 degree centigrade. So both are the same temperature. Just the reverse process happens. When you are saying melting point, you would say the definition is particular temperature at which solid changes into liquid. When you are saying it freezing point, you say that a liquid is changing into solid. So just that minute difference, the rest are same. So these are the melting and freezing point. Okay, now we move on quickly to the next topic. I hope you have noted it down. If you have not noted it down, you may pause the video and note it down and move on. Okay, so coming on to the next process that I am going to define is boiling. What is boiling? Again, let us see what is boiling. It is a process. I repeat, it is a process, not temperature. It is a process in which a liquid changes into a gas. Okay, so it is a process in which a liquid changes into gas. This process, which I have mentioned as boiling, is also known as vaporization. Okay, sorry, I have forgot to mention one thing in the definition. Process in which liquid changes into gas at a particular temperature. Please students, do not miss out this point, at a particular temperature. This is very important point. A very important point. You have to mention it. Now some of you might be thinking, sir, this process is also called evaporation. No, sorry, I am very sorry to say that evaporation is not the same thing as boiling or vaporization is. When I say of evaporation, evaporation. You will say that, sir, evaporation means also a process in which a liquid changes into a gas. We say that water is evaporating into the atmosphere. Yes, you are very correct, but there is a difference. There is a difference, and there are quite a few difference between these two, evaporation and boiling. So what are the basic differences between evaporation and boiling? Let us see it. So if I think of evaporation and boiling, see, when I have defined boiling, I am saying that this boiling process occurs at a particular temperature. I think you have noted it down. If I think of evaporation, I would say the same definition with slight modification. Evaporation, how can this term be defined? Evaporation, it is a process in which liquid changes into gas at any temperature. Have you noticed the difference? In the previous definition I have mentioned at a particular temperature. Here I am mentioning at any temperature. So I hope everybody have noted the difference. You see, generally when some water has accidentally fallen on the floor, you always do not wipe it out. You leave it as it is. After some times you see that this evaporation, that the water has vanished. So at that time the process that is taking place, I can say it as evaporation, not boiling, because you have not seen the water to boil. Boil means there are bubbles on the surface of the water. For example, another example I can say, in the very hot summer, you see that the ponds, lakes, rivers dries up, but you don't see the water to boil, but the water is slowly getting changed into vapor. That is why the rivers, lakes or ponds dries up, the water levels goes down. That process is evaporation, not boiling, because temperature has not reached a particular fixed value. Water boils at 100 degrees centigrade, but normally water evaporates at even 30 degrees centigrade, 25 degrees centigrade room temperature. So that process is evaporation. So based on that, I can give you a chart by which you can actually distinguish between these two processes, evaporation and boiling. Evaporation and boiling. So just note it down, boiling, on the other side evaporation. Okay, so these are the two processes that I am going to differentiate. Point number 1, occurs at fixed temperature, okay, fixed temperature, whereas evaporation occurs at any temperature. This is the first difference. I have also mentioned it in the definition. Next point is boiling. Boiling does not provide any cooling effect. You see, when water boils, even if you move your hand a little bit to the boiling water, you feel the heat. Even if you accidentally put your hand in the boiling water, it gets totally burned. Please never put your hand in the boiling water. It will be a tremendous accident. You see that we can feel the heat of that water from a big distance. Okay, but when evaporation occurs, there is a cooling effect. You see, when they say on the very hot summer, in some houses there are open lawns, okay, cemented lawns, and throughout the afternoon it becomes very hot, very hot after the afternoon. So at the evening, when you try to cool down that lawn, what do? You just pour a bucket of water. That water slowly takes up the heat from the surface of the lawn. It gets evaporated and changes into vapor, making the lawn to cool down. You can see it. Okay, so boiling does not have cooling effect. Fine, does not have cooling effect, whereas evaporation has cooling effect, fine. What is the third point? Third point is boiling is a bulk phenomenon. What does that mean? Bulk phenomenon. You see, when water boils, if you take a glass container, you can see that the bubbles are coming from the end of the container, base of the container. So throughout the liquid mass, the boiling process is happening. So that is why it is referred to as a bulk phenomenon. Whereas evaporation, you see, it's a surface phenomenon only. Surface phenomenon. Okay. So it just, evaporation of water just takes from the surface. It takes place from the surface. Okay, fine. So broadly you can see these are the three differences between boiling and evaporations. These are the main differences, rather I should say main differences. So I think now boiling and evaporation is very clear to you. I hope you have noted it down. Now let us move on to the next point. The next point is condensation. So it's just the reverse of the process boiling. What do you mean by condensation? How can you define it? So coming to the point, condensation, again I will define it as it is a process. It is a process in which a gas changes into liquid at a particular temperature. Again that same point I am repeating it, at a particular temperature. Never forget to mention this particular point, at a particular temperature. So that is condensation. So condensation is process in which gas changes into liquid at a particular temperature. Fine. Okay. Now, so these are the condensation and boiling. Now there is another term, as you have learnt of the term melting point. Likewise, there is a term which is called the boiling point. So what is that boiling point? Let us come to that definition. What is boiling point? Boiling point, I can define this boiling point. Again I am saying it is a temperature. It is a particular temperature. Remember, it is not a process. It is not a process. It is a particular temperature. It is a particular temperature at which liquid changes into gas. Okay, so it's a particular temperature. You have to remember, whenever you see this term point, you understand it that we have to write temperature. Okay, so boiling point is a particular temperature at which liquid changes into a gas. Fine. I can give you an example that when water boils, it boils at a temperature of 100 degrees centigrade. So I can refer that to as the boiling point of water. Likewise, you can also define as the condensation point. Both are the same things. Condensation point, if you want to write it down, you may note it down. Condensation point is a particular temperature at which the gas changes into liquid. Just the reverse. Here the liquid changes into gas. For condensation point, you will mention that the gas is changing into liquid. So nothing same, nothing different, only that last point will be different. Okay, so same structure of definition is same, just you have to mention for condensation point gas changes into liquid. Okay, so students, till now we have discussed the conversion of solid into liquid to solid, and then liquid to gas and gas to liquid. Today we will end our class here. Please do see our next class to understand the processes of sublimation, solidification or deposition, and I will also try to, that will be the last class I think on matter, and in that class I will try to discuss about the plasma state and Bose-Einstein condensate a little bit. So till then, thank you all. Visit us on the next class and don't forget to press the subscribe button, press the bell icon, and please do like our video and mention anything in the comment section. If you have any query, you can also mail us, that has been given in the description box. So thank you, please visit us again.